Okay, so today we had a two-part exit ticket. The first part was about parallel lines, and specifically we wanted to find an equation of a line that is parallel to this line. This equation models the line y equals 3x plus 4. So let's think about parallel lines. Parallel lines are lines that never cross, so they're next to each other, but they never will meet. They're always the same distance apart. The same distance here, same distance here, same distance here, same distance here. In fact, a real-world example is railroad tracks, which this kind of looks like. So railroad tracks are parallel, lines on your line paper are parallel, anything like that. Anything where those lines just never touch. So in order to make sure they never touch, there's something that has to be similar about them, and that thing is their slope. So remember, y equals mx plus b. For parallel lines, the m, which is the slope, is the same. So if we wanted to write an equation of a line parallel to y equals 3x plus 4, we could do something like y equals 3x plus 2. We could do something like y equals 3x minus 6. We could do something like y equals 3x plus a million. And the reason we can do that is because since the slope is the same, those lines will never, ever, ever touch. The only thing that's different is their starting point. They're starting a little bit further apart from each other, and here, way further apart from each other, a million apart. But since the slope is the same, they'll never touch, never in a million years. So any of these answers would be acceptable for that. In fact, you can just choose whatever b you want. It doesn't matter. Okay. Our next question was about perpendicular lines. So here we had an equation, y equals 2x minus 3, and we wanted to find an equation of a line that's perpendicular to it. Now, perpendicular lines are almost the exact opposite of parallel. Perpendicular lines always cross, and they cross specifically at a 90-degree angle, and that's really important. And that's what determines what our new slope is going to be. So in order for those lines to cross specifically at a 90-degree angle, we need to find the opposite reciprocal of the original slope. So let's break that down. First, our original slope, remember, y equals mx plus b. In this case, our original slope is m equals 2, right? Right here. We want to find the opposite reciprocal of that. Let's work with our first word, opposite. That means we change the sign. If it's positive, we change it to negative. If it's negative, we change it to positive. Here we have an originally positive slope, so we're going to change it to negative. So let's say our new slope, new m, is going to equal something negative. And then we have to find the reciprocal. Reciprocal is just a fancy way of saying upside down. So the number 2 is the same thing as saying 2 over 1, right? There's an invisible 1 underneath it because 2 divided by 1 is 2. If we want to find the reciprocal, we're going to turn that upside down. So that'll turn into 1 over 2. And now we have the opposite reciprocal, negative 1 over 2. And that's our new slope. We're going to keep the same b just for ease of use. So the correct answer for this one is an equation of a line that is perpendicular to y equals 2x minus 3 is going to be y equals negative 1/2 x minus 3. We kept the same b, but what's really important is we changed that slope, this m right here. This is what's important. We changed the sign from positive to negative, and we flipped the whole thing upside down. It used to be 2 over 1, we changed it to 1 over 2. So if we were to graph this, we would know we'd have to go down 1 and then over 2. So again, the slope to a perpendicular line is the opposite reciprocal, which means you change the sign and you flip it upside down. So here I've got 2 more problems that I want you to do. The first one, I'd like you to find parallel. Write an equation of a parallel line. And the second one, I want you to find a line that's perpendicular. Okay, so that's perpendicular, and that's a little illustration of parallel. So do those out, and if you get it right, then you have mastered these objectives.